Chapter 10 talks about classes of operation, and these are amplifier classes of operation. And the class, the designation of a class has to do with a couple of things. One is angle of conduction, how many degrees of the sine wave that the transistor is responsible to amplify, but also for power dissipation. So we start off with class A operation, and in class A, one transistor drives the output for the full sine wave 360 degrees. It's also conducting all the time in the DC voltages and currents. It's always conducting current. It always has a voltage across it, so it's dissipating some power even if you don't have a signal going in. And we've played with class A amplifiers, and that's your common emitter amplifier. In a class B amplifier, we have two transistors that drive the output over the full sine wave. So each transistor does about 180 degrees of conduction. But when there's no signal, they're both pretty much off. So if you don't have a signal going in, the class B doesn't dissipate a lot of power. In a class C, now a class C amplifier uses one transistor again that drives the output, but it only does it half the time or possibly even less. So the class C amplifier uses a resonant circuit, like an LC tuned circuit, which resonates at a specific frequency. And what happens is that when you input a signal, these little high voltages here, this only works on the high voltages, when you have these positive inputs, it turns the transistor on and it pulls this point down for a little bit. And that gets the LC circuit resonating. So you don't have to turn it on all the time. You only have to turn it on once in a while. And you could even turn it on occasionally. If you think of it like a swing, if you push a child on a swing, you don't have to push them very often to keep them moving. And that's the same thing here. You really only have to give the transistor a shot in these peaks here, and then the LC tank circuit will naturally resonate at that frequency. And that's what goes out to the load. Now the important one that we want to look at in Chapter 10 is the Class B push-pull amplifier. This is used in a ton of things to turn things on and off, amplifier circuits, stereos, motor drivers, pretty much anything that pushes like an RC car where things go in forward and reverse at variable speed. A lot of that stuff is done with a push-pull amplifier. And a push-pull amplifier, how you make a push-pull amplifier is you start off and you take one common collector amplifier. So here's a common collector amplifier which we've looked at in class, and this one's done with an NPN transistor. And what you want to do to make a push-pull is you want to bias the common collector amplifier so it's really in cutoff. So here an example, I got a 10k ohm resistor and an 820 ohm resistor as my biasing resistors. If you do the math on that, that would mean that the base voltage would be about 10 times 820 over 10.82k, comes out to about 0.76 volts. Well, 0.76 volts on the base, that's barely enough to turn this transistor on. So it really sits down here in cutoff. The Q point is down here and basically in cutoff. And it's not conducting a lot of current. And in actual fact, the 0.76, that's not what really appears on the base of the transistor. If you recall, the 0.76 volts, that's the Thevenin voltage, and that's for the base drive circuit. So this is 0.76. This would be even less after the base resistor, the Thevenin resistance of these two guys. So there's not a lot of base current there. Transistor is effectively off. And so it's sitting at the Q point down here. So to make a push-pull amp, you start off with one CC amp and you bias it so it's down here and cut off. Now what will happen is if you put a signal in, so here's a signal coming in, a sine wave coming in. If you have a positive signal in, that will pull the base voltage up, which will result in more base emitter current. And that'll turn this transistor on and it'll actually push current out to the load and you'll actually get an output. However, if you have a negative signal coming in, if this point dips down, then if this dips down a little bit, well, it was already sitting at 0.7. If this dips down 100 millivolts, that takes us down to 0.6. This transistor is off. It turns the transistor off completely. And for negative inputs, you'll get no output out of this transistor. You'll only see the positive cycle. Now what we want to do for the push-pull is we want to take a second CE amp using the other kind of transistor. Well, how do you do that? Let me just take a look here. And we haven't dealt with the other kind of transistor much. So if you're thinking about the other kind of transistor, this is how you should kind of think of it. So this is our standard NPN transistor to make a common collector. And you can see that the 10K is up here and the 820 is down here. And here's the load. Well, if you want to make the same circuit with the other kind of transistor, then what you do is you just kind of draw a line across the center here and you flip the circuit vertically. So basically you flip the circuit vertically, and what's going to happen is this 10K is going to get down here and the 820 is going to be up there. So if I flip this, now you can see the 820 is at the top and the 10K is down there, and I draw in the other kind of transistor. Now you've got a common collector amplifier in a PNP. And the currents flow, they still flow from 10 volts here, this is plus voltage here, they still flow from positive down to ground. So this would be the current flows this way. You would pull current out of the base, which would turn this transistor on a little bit. The load is up at the top now, while with the other one it was down at the bottom. So everything gets flipped over. And this is one of the ways that you can actually figure out the voltage divider on the PNPs, is you just kind of turn them into NPNs. You do the math and you do the base currents, and then you flip it over and you draw it. And it's the same base currents. So that's how you deal with that's how you create a second CC amp made with a PNP, and how we would bring that into the circuit. So what we would do is we would bring that into this circuit over here. And what we would do is we would kind of slide that up over here like this. So here would be our push circuit, and that would be pushing current out to a load. And then we would slide up the NPN transistor, common collector amplifier, up underneath that. And what you'll notice is that current is flowing this way, but this is ground. This is 0 volts here, and this is also 0 volts here. And since these are the same voltage, what I can do with this is I can actually join these 2 points, and I can merge these 2 circuits together into a single circuit. So I would merge them together like so. There you go. I've tacked on the PNP version down to the bottom, and I have the NPN at the top. And now I've got a push-pull circuit. If the voltage is positive, this one gets turned on and I get a voltage out of here. I get the positive peak out of here. If this goes negative, this one turns on. But if it goes negative, it pulls this point down, which pulls a little bit more base current this way, and turns this guy on, so it will pull current out of ground and take the load negative. So this is how you make a push-pull amp. You take 2 CC amps, one with an NPN, one with a PNP, you join them together at the ground point, and now you drive them both at the base. So you would apply your input signal here, which would take the signal to both bases. You would wiggle both bases the same, turn them on and off, but opposite. When you turn this one on, you turn that one off, and you would get a signal out of it.